talk on reaping benefits with web workers in Angular. Did you ever, as an early dev, write something like this? That is, you notice that your heavy task method took some time to complete, and the web page kind of froze. And as an attempt to save something of the situation, you thought, well, I'll just add a loading screen before I perform my heavy task, but quickly realized that the loading component didn't even show up. So early on, myself working in .NET and Angular, I figured that we should just delegate the resource-intensive tasks to the backend, allowing the front end to deal with the lighter tasks. But there are some reasons why you might not have this as a go-to solution. So what if you need to do a task, but on a large set of data? It can become problematic if data transfer is costly, and you have to send over megabytes or even gigabytes over the internet. Also, offloading tasks to the backend introduces network latency, as the client needs to send a request and wait for the response. Finally, what if we don't have a backend? Given the accessible cloud infrastructure nowadays, it's possible that we might not even have a backend at all. So what could we do about it? Well, you might already have guessed it. Today we'll reap the benefits with web workers, and after this talk, you will be well versed in understanding what a web worker is and its potential benefits, integrating web workers within the Angular framework, and examining real-world examples of how web workers can be utilized in Angular applications. So web workers are fantastic, but they're not new. At the World Wide Web Consortium, we can see that the first draft dates back to 2009, so 14 years ago. But given the limited content I thought about them in an Angular context, I figured that this could be a useful talk. So if you want to write some sleek, smooth, and snappy web apps, well then web workers might just be for you. The reason why the first example did not work is because JavaScript is single-threaded. In a single-threaded environment, the JavaScript code is executed in a single sequence, meaning that while the browser is executing a piece of JavaScript code, it can't do anything else, like updating the UI or responding to user events. So what are web workers? It's a specification that defines an API for running scripts in the background independently of any UI scripts. Web workers run in a separate execution context, isolated from the main thread. This means that they don't have access to the DOM or the main JavaScript context. Instead, they run in their own dedicated environment, which allows them to perform tasks without interfering with the main thread's responsiveness. Each web worker is executed in its own thread, which means they can take full advantage of multi-core processors, improving the overall performance of web applications and the experience of your users. So let's take a look at a first example. A prime number is a number greater than 1 that is only divisible by itself or 1. The first prime number is 2, followed by 3, 5, 7. The fifth prime number is 11. And computing the nth prime number can take some heavy computation. So here we see the loading bar, but it's not moving. We can see from the spinning loading indicator in our tab that the browser is loading and that the millionth prime number eventually pops up, but that's it. We can't see the progress bar moving because the UI is frozen during the computation phase. So yeah, I think we can do better. Let's use a web worker. So in this example, in comparison to the previous one, we'll delegate the heavy computing to our web worker thread, allowing the UI, our main thread, to use its resources to render the progress bar instead. So let's try to build this. First off, we start off with a CLI. The Angular CLI has excellent support to generate web workers. It's as easy as writing ng-generate web worker, followed by the location and the name of the worker. This will generate a web worker and help us register it in our Angular project. To be more specific, it looks something like this as of Angular version 15. A web worker will be added. It's a TypeScript file with a few lines of code that includes an event listener that listens for incoming messages. Web workers and the main thread communicate through a message passaging system They use the post message method to send messages, and they can use event handlers for the on message event to receive them. On the other end, we have our app component, which, just like the web worker, can receive and post messages to its counterpart. So here we instantiate a new web worker by providing the URL path. We can then use the reference of the spawned web worker to listen to incoming messages and to send messages. It's recommended to always have a fallback if web workers are not supported, so your app behaves correctly in any environment. But like previously mentioned, though, web workers has been around for a while, so it's supported in most modern browsers. Finally, a tsconfig worker JSON file is added, to which will be used in the build step. The configuration is used to make sure that we have our web worker file in the generated list folder after we have built our application and are ready to ship it. And similar to other configuration files, we register our web worker tsconfig file in our Angular JSON file. So where does web workers fit in Angular? The short and easy answer is nobody really knows. However, Angular has one great building block when it comes to integrating web workers into your application, and that is through services. We can create a web worker service and handle the communication in a more Angular-esque way, which makes our lives way easier. So here we can see that we have created a web worker service, which is provided in root. When the service is instantiated, we will create a web worker, and now we can communicate with our web worker through our web worker service. So today, this is the contract that we are going to adhere to when we are communicating with our service. As the task name implies, it's the name of the task that the response is related to. We currently only have one task, find env prime, but we could theoretically have more. Task event, that is the type of event represented by the response. So it helps the main thread understand the purpose of the response. For example, whether the response contains the final result or of the task or an intermediate progress update. ID is the task ID for a particularly spawned task. Payload is the original payload sent to us from the main thread as part of the task message. This field is useful for associating the response with the original request. So in our case, it could be like the 10th or the millionth prime number. And then result, the data associated with the response. So for a result event, this field will contain the final result of the task. And for a progress event, this field will contain intermediate progress information, such as the percentage of completion. So here we can see how we are going to expose the post message method in the web worker service to the rest of our app in more detail. So we create a method in our service called post message, which returns a newly created observable. The observable posts the message to the web worker with also the post message method, but for the web worker, we can see it on line 37, as well as setting up event handlers on the message and on error event. Given a message, we simply pass the value to any observer through the next method, provided that the message has the same ID as the ID of the spawn task. And if we, on message, receive a task event of result, we conclude that the observable stream has completed, and we notify our observers by calling the observer complete method. And on an error, we notify the observers through the error method. And as a reminder, the return statement in an observable is the cleanup function that will run upon completion. So here we remove any event listeners when the task is completed or when we unsubscribe. And then we have our app worker, which has one job, and that is to handle incoming messages. It checks the task name if it is find env prime, and if it is, then it calls the find env prime function. And if not, it just throws an error. And as soon as we have the result, we post the message to our web worker service, which requested the job. And in the find env prime method, we also send intermediate states to allow the subscribers to plot out a loading bar. The important part here is not really the implementation details, but just the fact that this is possible, and it allows us to deliver more improved user experience to our users, since they will be informed on what's going on during computation time. So now we only have to hook up our component. We call the post message method from our web worker service and subscribe to the return observable. We listen to the incoming messages and set the result and progress bar depending on what task event is emitted. We add some HTML, some classes to it, and voila, we have our snappy calculate the million prime number app ready to go. Some notes to take, which we need to remember when we send data between our threads. First and foremost, it's a requirement that the data is serializable. We can serialize primitive types, such as strings, numbers, booleans, objects, such as plain objects and arrays, but also dates, regex, blob, and file objects, which are serializable through structured clone. That means that we can't serialize things such as functions, classes, and DOM elements. So there are a couple of situations where web workers can be really beneficial. Image filtering, video editing, audio processing, data transformation, searching and indexing, they all share the same resource-intensive nature. So to demonstrate, we can check out this image filter where we use a web worker in the background. Every time we drag the slider and we iterate over each pixel and calculate the new color of the image. So the larger the image, the more pixels we have to visit and modify. So in this example, we do not use a web worker. And we can see that the drop-down menu opens as soon as the image filter has been applied. So that is, the image filter is blocking the drop-down menu from appearing for a brief moment. Another situation where web workers can be are really important are when we try to build apps that run smoothly on devices with lower processing power. If we look at the smartphone market, it's worth mentioning that flagship phones that many of us are using today is not necessarily what everyone else in the rest of the world are using. The number of smartphones have increased significantly during recent years, and although many of these phones uses modern browsers, they have far less processing power, and this will naturally result in a more burnt out main thread, which is a great reason why you might want to consider adopting web workers. Now, there are naturally some drawbacks to web workers. One that many has noticed probably is that web workers add complexity to our code base. You will need to manage communication between the main thread and the worker thread, handle error scenarios, and deal with synchronization issues. So that doesn't come for free. And we're also quite restricted on what we can send between our worker thread and the main thread. So this reduces the strong need of them for some applications where these are really important. Web workers are not always a slam dunk. Finally, web workers do not necessarily make the app faster. It's sometimes the opposite. It can become slower. But the improved responsiveness and feedback will often make the application appear significantly more performant and fast. So, in the beginning of the talk, I mentioned my early hypothesis on how we should delegate the resource-intensive tasks to the backend and allow the frontend to deal with the lighter tasks. This does not have to be the case, as web workers can do a lot of the heavy lifting in the front end. But what still holds is that the main thread that bootstraps our application, handles the UI, should not focus on having to do all the heavy lifting itself. Angular has great support for web workers today, and services are a great way to encapsulate your web workers and integrate them into your existing front-end architecture. Adopting web workers can often improve the perceived performance, not because the task finishes more quickly, but because the UI is freed up from resource-intensive tasks, allowing it to respond to the user events. And finally, a performant app is a more accessible app, and web workers can play a significant role in achieving that performance. It might lead to an improved bottom line, but it will always result in a happier user base. So remember to always prioritize your user and explore how web workers can contribute to a better experience for them. I highly recommend Surma's blog article, When Should You Be Using Web Workers, for those interested in learning more about web workers. Additionally, the Angular documentation features a concise chapter on web workers that is worth exploring. And lastly, don't forget to visit the Mozilla Developer Network, which always provides great resources on web topics. Feel free to connect with me if you would like to continue discussing web workers or Angular. Special thanks to Adi, who keeps making these fantastic conferences, to all excellent speakers who I'm fortunate to be accompanied by, and for everyone who attended. Thank you.